So here we have 2017 question 7. This is Leaving Cert Ordinary Level, and this is a question on sequences and series. So we're given 3 patterns. So the first pattern we have 1, 2, 3 across, and then the next one you have 1, 2, 3, 4 across, and the next one you have 1, 2, 3, 4, 5 across. And if we look at how many we have down, this one we have 1 down. So starting from we have 1, 2, then 1, 2, 3, then we have 1, 2, 3, 4. So in the next one we'll have 6 across and 5 down. So we'll have 1, 2, 3, 4, 5, 6. So I've already drawn this just to save time. 1, 2, 3, 4, 5. And then it asks us to do pattern numbers for the number of tiles for each pattern number. So in the first one we have 3 across, and then we have plus 1 on each of here. So 3 plus 2 is 5. So I've put in 5 for there. The next one I've written in 8. So we have 1, 2, 3, 4 plus double plus 2 and 2. So 4, 5, 6, 8. The next one I have put in 11. So we have 1, 2, 3, 4, 5 plus 3 and 3. So 5 plus 6 is 11. Then the next one 1, 2, 3, 4, 5, 6 plus 4 is 14. And then the next one we'll have 7, so it'll be 7 all together. So it'll be 7 kind of this way, and then going down it'll be 1, 2, 3, 4. So that'll be 5 on each. So it'll be 7 plus 10. So it will be 17. So then we on the next part C, part 1. We're told, assuming the pattern continues, the number of tiles in the end pattern of the sequence is given by the formula. So Tn is equal to Pn plus Q. So I noticed that I have an n here and not an n squares. That means it's going to be a linear, or we could also call it an arithmetic sequence. And in this sequence, we have a constant first difference between terms. So when I have a linear sequence, there is a formula to get the general term of a linear sequence, and it's in my log table. So what I do first is I go to the page where I have all my contents, and then I go to sequences and series, which is page 22. So and then it's this formula here. So that's the arithmetic sequence. So A is the first term, D is the common difference. The next one here is to add up all the terms. So we're going to want the first one here. So it's Tn is equal to A plus n minus 1 D. So where A is equal to the first term and D is the common difference. So we might not always be told that it's an arithmetic sequence. So I just want to show how we can actually tell. So the number of tiles we have, so we got from this is 5, 8, 11, 14. So I'll just do them. So 5, 8, 11, 14. So if I want to get the common difference, just to make sure there is a constant first difference for it to be a linear sequence, I just have to get the difference between one term and the next. So from 5 to 8, there's a jump of 3, 8 to 11, there's a jump of 3, and here there's a jump of 3. So the difference between all the terms is called the first difference, and the first difference is the same here. So it's a constant first difference, so my constant first difference is 3. So D is my common difference, so that's 3. And then A is the number of tiles in the first pattern, so it's going to be 5. So A is equal to 5. I'm just going to write down my formula again. So A plus n minus 1D. So I'm going to sub in A is 5 and D is 3. So 5 plus n minus 1, 3. So 5 plus, I'm multiplying 3 by n and 3 by minus 1. So 3n minus 3. So that'll be 2 plus 3n. So, but they wanted it in the form Pn plus Q. So I'll write it as Tn is equal to 3n plus 2. So in this case, P would be equal to 3 and then Q would be equal to 2. If I'm so my P is going to be this one attached to the N, and my Q is going to be my other constant. So that's going to be my general term that I can plug in any value for N, the stage number, and then get the amount of tiles in that pattern. So now that I have that, that's going to be useful for the rest of my questions. So I'm just going to write this on the top of my page, T3N plus 2. So what I stick in for N is the pattern number. What I get out is the number of tiles in that pattern number. So if I want to get how many tiles are in the 20th pattern, well, I stick in the pattern number for N. So I stick in N is equal to 20. So 3 by 20 plus 2. So that's going to give me 62 tiles in the 20th pattern. And then I'm asked to find which pattern has exactly 290 tiles. So my general term, Tn plus 2, and that's equal to the number of tiles in that in a value of that pattern number. So I stick in my pattern number, and that's equal to the number of tiles in that pattern number. So if I want to figure out what pattern number, what value for N has 290, I don't stick in 290 for N, I stick it into let that equal to 290. So 3N plus 2 is equal to 290. So 3N is equal to 290 take 2. So 3N is equal to 288. And now I'm going to divide both sides by 3 to get what N is. So then I get N is equal to 96. So which pattern? So it's going to be the 96th pattern has exactly 290 tiles. And then my next part, I was asked to, so I'm going to write my general term up at the top because it might be handy for me. So show that Sn is a formula for the total number of tiles needed to build the first n patterns. So if I want to show this, so Sn is the sum of all the terms in the pattern. So say if I have T1, so Sn is when everything is added together. So that would be the number of tiles in T1 plus T2 plus T3, and it will continue on until we get to a given value of, say, Tn. So it's adding them all together. So if we look back at our pattern, so it'll be 5 plus 8 all the way to a given value. So it'll be 5 plus 8, because 5 is the number of tiles in our first one, plus 11 all the way up to a certain value of Tn added together. So the sum of all the terms in arithmetic series is a series is when we add all the terms together, and then a sequence is when it's just the terms. So this is the formula for a series. So when we're adding them together, so the sum is n over 2a plus n minus 1d. So it's asked is a formula needed to build for the number of tiles in the pattern. So they want the number of tiles in, say, in the first n. So we're going to have it in terms of n because it's in the first n pattern. So we're going to leave n as it is, but we do know that the first number a is the first term, and d is the common difference. So the first term we got was 5. The common difference we got already was 3, because remember we did out our differences and we got 3. So I'm going to sub in a equals 5 and d equals 3. So that'll be n over 2 2 by 5 plus n minus 1 by 3. And they haven't given me a pattern number, so I have to leave my n as it is. So that'll be n over 2, so that'll be 10. So 3 by n gives me 3n. 3 by minus 1 gives me minus 3. So then I get n over 2, so that'll be 10 take 3, which is 7, plus 3n. So I can put that all over 2. So that'll go as n all over 2, and then 7 plus 3n. So then I multiply n by everything, so that'll be 7n plus 3n squared over 2. And if I want to put it in exactly their format, Sn is equal to 3n squared plus 7n over 2. So that's exactly the way they had it. So I had to use the sum of the terms in an arithmetic sequence. So now that I know, so Sn gives, say if I have, so my terms are, I had 5 and then 8 and then 11 and then 14. If I want to get the sum, so the formula for to get the sum of everything is Sn is 3n squared plus 7n over 2. If I want to get the sum of add all these, the first 4 together, well, I just have to let n equal 4, and that'd get 5 plus 8 plus 11 plus 14, and that would add them together for me. So I was asked to find the total number of tiles needed to build the first 30 patterns. So that means they want the sum of the number of tiles in pattern number 1 plus the number of tiles in pattern number 2 plus the number of tiles in pattern number 3 all the way up to pattern number 30. So I'm going to have to get the sum. So I know in general terms in n it's 3n squared plus 7n over 2. But I want to get the sum of the first 30, so I'm going to let n equal 30. So S of 30 is 330 squared plus 7 by 30 over 2. So if I just work that out, so it'll be 330 squared plus 7 by 30 over 2, and this is what I plug into my calculator, and then I get that is equal to 1455. So that's the total number of tiles in all the patterns up to pattern number 30, and that is my answer for that question.